Now let's look at area under the curve. The total area under that normal curve is always going to add up to be 1. And so we know that the mean is right in the middle. So half of the area is going to fall to the left of the mean or below the mean, and half of the area will fall above the mean or to the right of the mean. Now there's a table in your textbook, and you're going to have you'll have this as a reference when you take your test, but it's called the standard normal table, and there are two parts to that table. The first table, and if you'll look here, we've got the z-scores. All of these are negative, and the table, the actual entries here, all of these numbers are the area under the curve. And so, and make sure that you realize that the table entry is for the z-score to the area of the left of the z-score. So it's the area under the curve, but to the left of the z-score always. So if their z-score is negative, which in this picture you can see the z-score would be negative since the mean is here, then I would look on this chart at whatever z-score this was. Let's pretend, and I can even write this in, that this was a negative 1.54 as the z-score. And if I wanted to know the area under the curve, I'm going to go, this would be the area to the left of the z-score under the curve. I'd look for a z-score of a negative 1.5, and then to go further in decimal places, we would go to the top of the table, which is here. You notice that this column would include the 0.04. So let's go back down to negative 1.54. So the area under this part of the curve would be 0.0618. Now this also means that if we wanted instead to find the area to the right of a certain z-score, so instead of this part, if we want the area to the right of the z-score, we would first look up, like we did before, the area to the left, and remember that the total area under the curve is 1. So we would take 1 and subtract the area that we just found. I'm going to do that in the calculator. 1 minus 0.0618 would give me 0.9382. So that would be the area to the right of that z-score. Now the second part of the table has positive z-scores. And notice that we had already talked about this, but if the z-score is 0, now we know that that would be at the mean. Remember that these entries tell the area to the left of a z-score. So if the z-score was 0, which is our mean, look what it says for just 0.00. So that would be half of the data is to the left, 0.5, so the area would be 0.5. And then that would also be true of the area to the right. If we wanted this part, the area under the curve to the right of that z-score, it's also 0.5, because 1 minus the 0.5 we had already found leaves me with 0.5. So let's find the area under the curve if this z-score is 1.19. We want to find the area to the left of the z-score, so the colored in part at this point, if the z-score was 1.19. So we would go down to 1.1, and then we would look across to the column that includes the 9 in the hundredths place. So where these two columns intersect would be the area under the curve. So the area under the curve to the left of the z-score 1.19, the area would be 0.8834. Now if I wanted to find the area to the right of that same z-score, I would have 1 minus 0.8834, which would give me 0.1166. So that would be the area to the right. Let's look at this next example. It says to use the standard normal curve to determine the percent of data less than a z-score of 0.76. So in each of these you probably want to draw a little model of the normal curve with the mean in the middle, and then a standard, the z-score of 0.76, it's positive, so it doesn't matter exactly where you put it here, but it's just a little bit less than a z-score of 1, but that really doesn't matter. I'm going to just put it right here. So if I have a z-score of a 0.76, it is positive, so we've got to be to the right of the mean. Remember, the mean is 0. And if I want the area, first of all, we'll find the percent in a minute, but let's find the area that's to the left, because it is less than that z-score of 0.76, and that's what my table tells me. It always tells me the area that's to the left of that particular z-score. So if we go over on our chart, a 0.7 and go across to 0.76, which gives me an area of 0.7764. So the area is 0.7764, but I want to know the percent of the data. Remember, this is 0.7764 of a total of 1. So to get the percentage, we would multiply that by 100, moving the decimal place over 2, which would give me 77.64% of the data must fall to the left of that z-score or be less than that z-score of 0.76. Now remember that if this had said, so that had said less, but if it was greater than a z-score of 0.76, we'd be looking at this part and we would have subtracted 0.7764 from 1 and then multiplied by 100 to get the percentage there. We would end up with about 23% would be to the right of that z-score. On this problem, we want to use the standard normal curve to determine the area to the right of the z-score 1.95. So I'm going to again draw our normal curve. Go ahead and mark what that z-score of 0 would be. We know that's the median. So a positive 1.95. It doesn't matter exactly where you put it. We know it's a positive z-score, close to a z-score of 2. And we want the area to the right of that z-score, which would be this area. Remember, when we look it up on the chart is going to give us the area to the left. So we'll find that first. Go to 1.9 and we'll go across to 0.05. So the blue part here has an area that's 0.9744. But to find this area, the red shaded part would be the area to the right. Remember, the total area under the curve is 1. So we would take 1 and subtract 0.9744. Which gives me 0.0256. Right there. So the area to the right of the z-score would be 0.0256. Had you been asked for the percent of data under the curve, we'd multiply that by 100, which would give me 2.56%. But this particular problem asked for the area and not the percent. Now in this next problem, we're going to look for area between two z-scores. And the problem says to find the percent of data. So we know at the end we will want it to be in a percent of data between a z-score of a negative 1.22 and a z-score of 0.097. It's important that we look at that. Just do a quick sketch, remembering that the mean is in the middle with a z-score of 0. We've got a z-score of a negative 1.22. We know that's to the left of the mean. And a z-score of a 0.97, so real close to a z-score of positive 1. Okay, so we want to find this area. Okay, now remember that when we look up on the chart gives us, or the table gives us, the area to the left of a certain z-score. So I hope you can see that if we find the area to the left of 0.97, we're almost there. There's still this little bit of area that we don't want to include. So we'll actually take the area below or to the left of 0.97, but then we want to take off or subtract the area to the left of negative 1.22. So first let's find the area. Let's find the area below that 0.97. So let's go to our table. So the area below 0.9, go across all the way to 0.07 would be 0.8340. 0.8340. So that's all of this area including this red part. So we want to take away now, we're going to subtract the area to the left of the negative 1.22. So let's go again to, now we need to go to the chart that it contains the negative z-score values. So negative 1.22 would be 0.1112. 0.1112. And I want to subtract. We're going to take the red part away so that, because remember that we're just wanting the area that's in between those two z-scores. So it'll just be this area. So 0.8340 minus 0.1112. So when we subtract that, we would get 0.7228. And because we were asked to find a percent, we want to change that to, by multiplying by 100, 72.28%. So 72.28% would fall in this blue area between the z-score of negative 1.22 and 0.97. So notice again what we did. We found the area to the left of the higher z-score, and that would have included all of this part, including this below the negative 1.22. So since we only wanted the area between the two z-scores, you then need to subtract the area that would be below this negative 1.22. We found both of those values on our table and then subtracted them to get that value, changed it to a percent.